Hello and welcome to this tutorial. We're going to cover what you need to do to configure a router to support IP version 6. So we're going to start off by enabling IP version 6 on a router. Then we'll go ahead and we'll configure some interfaces with IP version 6 addresses. Now we're also going to review how to configure a routing protocol for IP version 6. In this tutorial, we're going to focus on RIP-NG, that's RIP Next Generation, which was designed to support IP version 6. The basic approach we'll be taking for RIP can also be applied to OSPF version 3, which is the version that supports IP version 6 as well. Okay, so let's go ahead and jump onto the lab. Now the first thing you need to do when configuring IP version 6 is to enable your router to support it, because by default Cisco routers only support IP version 4. So if you want to use IP version 6, you have to tell your router to do so. So in configuration mode, we have to enter the following global configuration command: IP version 6 unicast routing. Once you enter that, the router can now support it. If you don't have this command available to you, don't panic. It just means that you have to change your version of iOS because the current one you're using doesn't support IP version 6. Okay? So now that our router can support it, let's go ahead and configure an IP address. The command we want to use is nearly identical to what we use for IP version 4. It's just IP version 6 address. And then we have to go ahead and enter the hexadecimal digits. So you can see here, I'm going to go ahead and enter the prefix and then enable the EUI64 format. And that's it. It's as simple as that. Okay, so now that we've configured it, let's go ahead and take a look at the running configuration. You can see here for serial 000, the configuration command is exactly as I entered it. In other words, you do not see the full IP address for version 6 here. You only see that you have a prefix and you have it enabled to use the EUI64 format, but you do not see all 32 hexadecimal digits. In order to see that information, we need to move our attention from the running configuration and actually issue a few show commands. So we'll get out of configuration mode, and the first command we'll enter is show IP version 6 interface serial 000. We can see right off the top the interface is up and IP version 6 is enabled, and it immediately tells us our link local address. Remember the FE80? There it is. Right below that, we can see the global unicast address, and this is what we just configured, but now we see the entire address. First, it shows us all 32 hexadecimal digits, and then right after that, it tells us the prefix, the subnet that we actually entered already. The next command is a brief look at the interfaces. It is show IP version 6 interface brief. This will show you all of your interfaces, and as you can see, we only have IP version 6 addresses on serial 000. Now we know that FE80 is the link local, and just to point out something we talked about in one of the previous tutorials, you can see on the global unicast, since we use the EUI64 format, the interface ID portion of the address, you can see the FFFE. So now that we have IP addresses on our one interface, let's go ahead and take a look at the IP version 6 route table. The command is show IP v6 route. You are probably noticing a trend. All of these commands include the IPv6 in them. And here it is. Here's the route table. The first entry we see is a connected route. We know that because the code C indicates it's connected, and that tells us the subnet or the prefix on that interface, and that is via serial 000. The next entry after that has an L in front of it. That tells us this is a local address, And that IP address, you see the full 32 hexadecimal digits. It's a /128, and that is simply telling us the IP address configured on serial 000. Okay, so the connected routes are the same as IP version 4. That's nothing new. The L for local is new to us, and it will indicate the IP address on an interface. Okay, so our route table is pretty simple right now. After this, we're going to go ahead and set up RIP-NG, and then we'll see some of the routes that we learned from router B. Let's take a quick look at our lab, and we have routers A and B here, and they're connected via a serial connection. We will be making all of our configuration changes on router A. Router B is already configured, so if we do this properly, we will learn some routes via RIP on router A. Now the first thing you need to do is obviously have IP version 6 enabled and assign an IP version 6 address, and we've done that. The next two steps require us to create an instance of RIP on the router, and then go ahead and tell RIP which interfaces will be participating in RIP. We are back on router A, and the first thing we have to do is enable RIP with the following command: IPv6 router RIP, and then we have to give it a name, and this name is going to be used to identify or represent this instance of RIP. I will call ours fun because RIP and IP version 6 are fun. So now that it's enabled, we have to tell the router which interfaces will be participating. And this is where things change quite a bit from IP version 4. What we're going to do is we're actually going to go into the interface that we want to participate in RIP, and we'll enter the following command: IP version 6 RIP, and then the name of the instance, which is fun, and then enable. Okay, so the name that we just entered for this version, for this instance of RIP on the interface, has to match whichever instance of RIP we just configured. So if we had entered IP version 6 RIP George, if that was the name, it would not match and it would not work properly. Okay? Now, you'll notice that in IP version 6, we do not use the network command. And that was really big in IP version 4. And just to remind you, that was used to identify which subnets should be included in the routing protocol. Well, here, it's not needed, since the router knows which subnet to include by looking at the interface that was configured for RIP. So the router is going to see that serial 000 was configured for RIP, and it'll automatically know that the IP address configured on that interface will be participating in RIP. So now we have to confirm if RIP is working or not. The first command we can use to do that is show IP version 6 RIP. And this tells us a lot of information about the protocol itself. In the beginning, you can see the name of this particular process. It's fun. That makes sense because that's what we called it. We can see the administrative distance, the maximum paths, some timer information. And then at the bottom, you can see which interfaces are configured to participate in this instance of RIP. And here you see just one, serial 000, and that matches with the interface we just configured. The next command is to look again at our IP version 6 route table. And this time there's some more info. The first two entries are the same, our connected route and our local address. But then we see two entries with the letter R in front of them, and that indicates that they were learned via RIP. The first one is a prefix. It's a /64, and it's telling us that we can reach that prefix via FE80 230 80FF, and you can see the link local IP address there. So in IP version 6 routing protocols, oftentimes the link local address of the other side, of the other end of the circuit, is used as the next hop destination. So we can definitely see that here. Also in the next route, 2ABC1234. So that's another /64 that we've learned from router B. And again, it's telling us in order to get there, the next hop would be the link local address of router B's serial interface. The serial 000 is telling us which interface on our router, on router A, we would have to exit in order to get to this route. Okay? Now, one last point. We're not going to configure OSPF version 3 in this tutorial, and the specific commands are a little bit different. However, the same approach would be applied. First, you would create an instance of the OSPF, and then, again, you would enable it on the interfaces that you want to participate in OSPF. So you would not use the network commands for OSPF version 3 as well. So let's summarize what we talked about. We now know that IP version 6 is not enabled by default on Cisco routers, so we have to go ahead and do that. The command is IPv6 unicast routing, and once we have that enabled, we can go ahead and assign IP version 6 addresses. To confirm those configurations, we can issue the show IP version 6 interface command, and we can also put the brief parameter on the end to get a more consolidated view. And as we pointed out during the configurations, we see not only the address that we assigned, in our case the global unicast, but also the link local addresses. Then we took a look at the IP version 6 route table, and we see that we have connected prefixes as well as local routes that are assigned to the interfaces themselves. Now, if you need to enable RIP, you would do it like this: IP version 6 router RIP, and assign a name to it to identify it. Then, instead of using the network command like we did in IP version 4, just go ahead and jump into an interface, and you enable it to participate in RIP by assigning it to an instance, and that name has to match the instance that you just created. To confirm your RIP configurations, you can always enter the show IP version 6 RIP command. Okay, so that's it. That is IP version 6 configurations. Thanks for watching.